Hi guys, this is day 3 multiplication word problems. So these two word problems are one-step word problems, and then when you flip to the next day 3, numbers 3, 4, 5, and 6, these are going to be multi-step word problems. So what I'm going to do is I'm going to do one of each. So I'm going to do number 1 with y'all, and then I'll do number 3 with y'all, and then you can do the rest on your own. So again, just like with subtraction word problems, it's important that we really follow our RDWW strategy. So the first thing we need to do is read the problem. And remember, whenever we read the problem, we're reading the whole thing through, and then we're going to chunk it. The reason we read the whole thing through is so that our brains can begin to grasp what the problem is asking us to do. So let's look at number 1. It says Harold unpacked 14 cases of canned beans at the food pantry in his neighborhood. Each case contained 24 cans of beans. How many cans of beans did Harold unpack in all? So there's a lot of good information in this first one. Again, there's not much room for you to draw and write out your number, sentence, and statement. So again, over here, I have my computer paper to work it out. So let's chunk. This first sentence says Harold unpacked 14 cases of canned beans at the food pantry in his neighborhood. Okay, so we have the number 14. And this is representing the cases. Okay. Next, it says each case contained 24 cans of beans. So here is whenever you may have a tape diagram that you're going to have to modify, because we have 14 cases, but each case tells me that one case has 24. So I'm going to kind of redraw this out. I know that one case has 24 cans. Okay. However, we have 14 cases. So that would mean that I would need to draw 2 cases, 3 cases, 4 cases, 5 cases, 6 cases. However, that's a lot of cases to draw. So if you think back a while ago, remember when you have a ton of boxes to draw, what we're going to do is we're going to draw one large extended box, and we know that we have to multiply this by 14, because we have 14 cases. So one case with 24, but we have 14 cases. And then the question is asking us how many cans of beans did Harold pack in all? So again, this in all should tell you that you're solving for a total. So remember, when you're solving for a total, there's only 2 options we can go here. Goodness, my pencil keeps breaking. We can either add or we can multiply. But we know we didn't need to add because of this word each. And again, some of y'all may still have that handy dandy word problem anchor chart that I gave y'all a while back that lets you know some of the key words that you can look for in these word problems. All right, so now we know that we're solving for our total. So let's write out our number sentence. We need to multiply 24 times 14. So we need to draw out our area model. Seems like a lot of work, but it's all good. It's going to get us the right answer. Okay, so remember, we're going to break apart 24 into 20 plus 4. What you do to the top, you need to do to the bottom. Then we're going to break apart 14 into 10 plus 4. What you do to one side, you need to do to the other. And now we're ready to multiply to get our partial products. So 1 times 2 is 2, and 2 zeros, that would make 200. 4 times 10 we know is 40. 4 times 2 is 8, and 1 zero, which would be 80. And then 4 times 4 is 16. So now that we have our partial products, we can add those up. So 200 plus 80 plus 40 plus 16. So 0 plus 0 plus 0 plus 6, we know is 6. 0 plus 8 plus 4 plus 1. 8 plus 4, I know is 12, plus 1 more is 13. Again, if you didn't know that, you could use your touch points. 8, 9, 10, 11, 12, 13. You could also use counting on. Remember to add your 1 at the top. And then 2 plus 1 is 3. So our answer to 24 times 14 is 336. And now our last step is to write that statement. So how many cans of beans did Harold unpack in all? Harold unpacked 336 cans of beans. All right, so a little bit more work for these, but again, that's okay because we want to make sure we get the correct answer. So now you're going to do number 2 on your own. All right, let's look at number 3, okay? And hopefully I can put this in this little bitty spot here. Okay. So again, RDWW, read it. That means read it through all the way. Chunk it. We'll draw our picture. We'll write our number sentence, and then we'll write our statement. It says, Jason is asked to count how many basketballs there are to run relays. He finds 6 containers each having 12 basketballs. In addition, there are 4 shelves with 5 basketballs on each shelf. How many basketballs are there in all? All right, so I kind of have a grasp of what we need to be doing here, and I hope that you have a grasp of what we're going to do here. You will also notice that this one has more than one step, and I'm going to show you why. So let's chunk. So Jason asks to count how many basketballs there are to run relays. So in that first sentence, there's really not any good information that we could pull out. So let's look at our next one. He finds 6 containers each having 12 basketballs. Okay, so in this next sentence, we do have some good information. We have 6 containers, and they give us this word each. And they have 12 basketballs. So let's think about what that sentence is actually telling us. He finds 6 containers. Each container, so that means in one container, they have 12 basketballs. So that's what I'm going to draw. In one container, they have 12 basketballs. However, how many containers do they have? 6. So again, instead of drawing out, that would be 1 container, we would need to do 2 containers, 3 containers, 4 containers, 5 containers, 6 containers. But instead of drawing each one out, I'm just going to draw a bigger box. And I know that I'm going to have to multiply this times 6 to represent those 6 containers. So before I move on, what do you think is going to be important for us to do before I move to that next step? Well, of course, I'm going to need to solve this out. So I'm going to find the total of this box. So 12 times 6, which this one's easy if we know our math facts. If we know our math facts, we know that 12 times 6 is 72. So there really wasn't much work for that one, which is great. So we're going to put 72 at the top. Are we done? Nope. We've only chunked out this first sentence and second sentence, but there's another sentence. In addition. Oh, I love that. Okay. They have addition. Okay. So at one point, we know that we're going to have to do what? Add. There are 4 shelves with 5 basketballs on each shelf. So again, in this one, we have some good information. So it says that there are 4 shelves with 5 basketballs on each shelf. So again, they have this word each. So that means on one shelf, there's 5 basketballs. So I'm going to draw another tape diagram. Not inside. One shelf we know has 5 basketballs. However, we need how many shelves? 4 shelves. So this one you could draw out because it's really not that many. 2, 3, 4. So here's 2 shelves, 3 shelves, 4 shelves, and we know that each shelf has 5. So what are we going to have to do with this tape diagram? Well, just like we did for this one, we're going to want to solve for that total before we move on. Well, that's easy. We have 5. How many times? 4 times. So 5 times 4, which again, if you know your facts, is super easy, 20. So again, not much work to figure out that one. All right, are we done yet? Nope, because we still haven't gotten to our question. So we've done some work and we're almost to the finish line, but we need to make sure that we answer the question. It says, how many basketballs are there in all? So here's that in all. Again, we're looking for that total, which means we're either multiplying or adding. Well, don't forget that up here it said in addition. So what do you think we're going to have to do with these 2 totals? You're right, we're going to have to add those up. So our last and final tape diagram, we're going to write our 2 parts. So in our first part, we had 72. And then in our second part, we had 20. And if I want to know how much in all, remember we want to solve for our whole. So that means our tape diagram is showing us to add 72 plus 20. 2 plus 0 is 2, and 7 plus 2 is 9. So how many basketballs are there in all? There are 92 basketballs in all. So we're just going to put that in a statement. There are 92 basketballs in all. And there you go, guys. You got it. So over here in your blank, just go ahead and write your statement. There are 92 basketballs in all. And you'll notice they don't give you much room. On our key, it was very difficult for me to fit everything in, so I know it's going to be difficult for you. I highly suggest that you get out some scratch paper, anything that you can find, construction paper, loose leaf, computer paper, whatever you have at home, to work these out so that you can really see what's going on. All right, so you're going to do 4, 5, and 6. Lastly, for day 3, is this 7 and 8. And I want to explain this because it's not something that we've looked at much, and I want you to understand where they're coming from. It says multiplication can be solved by taking each digit from one number and multiplying it by the whole other number. For instance, 14 times 23 is equal to 10 times 23 plus 4 times 23. Use your own paper to double check this and prove that it is true. So where they're getting 10 times 23 is they are breaking apart this 14. Kind of like we break apart our numbers in our area model. So they're breaking apart 14, and we can break apart 14 into what? 10 plus 4. And what they're doing is they're taking each part and they're multiplying it by 23. So they're saying 10 times 23 plus, and then they're taking the second part, 4 times 23. And that's how they got that problem. So again, it looks a little similar to what we've done with our area models, but also a little bit different. So I wanted to show y'all that. So let's look at 7 and do this one together. And then 8, you'll do by yourself. The school cafeteria ordered 23 cases of tomatoes. Each case of tomatoes costs $34. Which equation shows a way to find the total cost of tomatoes? So we're going to break apart 23. So whenever we break apart 23, what will that break into? Well, we know 23 can be broken into 20 plus what? 3. Let me erase this a little bit. And then we're going to take each part and multiply it times 34. So 20 times 34. And then we want to add our second part, 3 times 24. 34, sorry. Okay, so now that I've written it out, it's going to be much easier to find in our answer choice. So if we look at A, does A match what we solved here? No, so that's not going to be correct. B, does B match? Yes, so I'll put a check, but we still need to check our other answer choices. Does C match what we wrote? No. And lastly, does D match what we wrote? No. So our only answer here would be B. All right, guys. Again, please make sure you draw out your tape diagrams. These are multi-step. Remember, the one on the previous page is one step. All right.